And I want to take a step back and take a more leisurely approach, because I'm not as bright as those two guys. So I wanted to give you a perspective of what I've been doing around OpenShift, and actually take you through a demo. So we've been given access to OpenShift on IBM Cloud, full administrator access, surprisingly. So we can actually see everything within OpenShift and what it's capable of. And I just wanted to show you as part of a demo. But before that, I just wanted to do a few slides in terms of setting a baseline for what Kubernetes is, and then the value of OpenShift on top of it. As part of the poll that we took, a lot of people said, yes, this is the direction that we're going to go down, but we're very early in it. And of course, the knowledge around Kubernetes in particular is pretty low at the moment, and it would be good to get a more in-depth view of that. So you'll get a very basic view from me as to what that is. So I just wanted to set that as a baseline. So from the presentation itself, I just wanted to start with, well, what is Kubernetes? Well, at its very lowest level, the smallest compute unit within it is a container. So that's a piece of code that's running that takes its information from an image. So the image contains the binaries and libraries associated with the container, and the container itself is the runtime version of it. So the image or the container is spawned from the image. And the image itself and the images are held within a registry. And the registry is a repository of the images themselves. And this is important. This is probably one of the first things to really understand when it comes to working in the new world within Kubernetes and OpenShift, is that the registry is very important, because that's where the images are kept. And that's the first question that you need to ask internally, is where those images are kept. Within IBM now, there is the IBM Container Registry, where you can actually pull the images associated with IWS either directly from the IBM registry itself, or hold it within a local registry, a repository within your own firewall. And that's the first piece really to get sorted out, is where you're going to store the images. So the images are kept within a registry and spawn the containers that run within your Kubernetes infrastructure. And the way those images are referenced within the registry itself is by name and also a tag as well. So in the example that we see here, there are two images, one for a front-end application and the other for MongoDB. And there are various versions of that image that are held. And you can see that you've got the application name, colon, and then the tag that's associated with it. So front end, we've got version 1, version 1.1, so on and so forth. And latest is the current version. So if you pull from the registry the application front end and you don't specify a tag, it will pull the latest version. And that's the same with IWS as well. So this is the standard mechanism for referencing images within the registry. And then the containers themselves run within something called a pod. And the pod is responsible for the deployment and management of the container or containers held within it. So you can have a pod with a single container, as you see on the left-hand side, or a pod with multiple containers. And when John was talking about an IWS agent as a sidecar, that's typically the image on the right-hand side. So you have an application container and you have an IWS agent container running within the same pod, and the IWS agent is known as a sidecar. Okay, so the next thing is replication controllers and replica sets. So you have your containers, you have your pods. How do you control the number of instances of the pods that are running? You can have multiple. So from an image, you have a replica set and a controller that determines how many of those pods run at any point. By default, with IWS, it's one. So within your replica set and the associated replication controller, it'll specify that you have a single instance of an agent running within a pod and one of those units that are spun up when you request a new deployment. So you can see the structure is pod, deployment, replica set. And within the deployments themselves, you control the versions that are actually deployed. So if you've got a deployment of the latest version, that's what it will pull in terms of the image. Or you can control a version based on a particular application requirement. So within the deployment and the deployment config is where you hold which version information you want to control, you want to have within the pod and the container. Okay, another term within Kubernetes which is important and is used quite a lot by IWS is secrets. So a secret is a mechanism for holding sensitive information like passwords. So what you could do is hold a password unencrypted as an environment variable at startup, but you don't want to do that because then people can see what your passwords are associated with IWS, for example. So you can actually hold that as an encrypted password as a secret. And with IWS, there's a number of secrets that are required, not just for the application itself, but also for the pull of the image as well from the IBM container repository, container registry. So understanding the term secrets is important for Kubernetes. Okay, the next term is services. So a service controls the number of deployments. It's a load balancing mechanism for typically, as in this example, the back end of an application. So you've got a single front end and a service that deploys multiple back end services. And then from that, you can link the front end to the service to then link onto your back end applications. And the applications can talk to each other via the service. And then you create a route through the ingress to make that application available to the outside world, whether that's through curl or anything else. So the routes are basically your network route to the front end and back end applications. And in terms of an operator can be seen as a service that deploys containers within pods within your Kubernetes environment. And that's an important thing to also realize, that is that an operator is a Kubernetes term and not an OpenShift term. OpenShift uses Kubernetes operators. Okay. So what is OpenShift? So OpenShift is a container orchestration platform that sits on top of Kubernetes. So as your Kubernetes infrastructure grows, how do you control it? How do you provide the automation and administration to help manage that underlying Kubernetes infrastructure, and also to secure it as well? So these are the different aspects that OpenShift provides. So it allows people to collaborate in a secure mechanism and scale your Kubernetes infrastructure. So it's an orchestration platform. And as Franco talked about this morning, the different services that are available on top of Kubernetes can be grouped into different areas. So we've got monitoring and logging, we've got the middleware piece, the application services, and then you've got the developer tools as well. So it's important to understand that OpenShift has two sides. There's the administration side, so what are you actually providing? And then the developer side, which is who are you providing it to and what can they do within your OpenShift infrastructure. And of course, this sits on top of Kubernetes, the underlying operating system, and we can provide it as platform as a service, containers as a service, or function as a service as well. So these are the kind of terms that are used within the new world. Okay, so this is another representation of what OpenShift is. So we can see the pieces in blue are what are provided as part of Kubernetes, and then the OpenShift pieces on top of that allow you to use some of the open source software that's also available. Franco spoke about Prometheus and Grafana. In terms of Prometheus is a monitoring application, and Grafana is it's a graphing kind of data collection and representation tool that's provided within OpenShift and Kubernetes. And then from a user point of view, there's the administration side of things, which we'll look at, and also the developer side as well. And we'll see from an IWS point of view, the benefits of both to OpenShift administrators and also developers as well. Okay, so deploying IWS within OpenShift 4, it was available within version 3, but it didn't use operators. Operators came in as part of a later version of Kubernetes, and therefore the management of those operators was provided in OpenShift 4.1, and within FixPack 2, we now have a mechanism for providing an IWS operator within OpenShift. So an operator is a way of building an application and driving that application on top of Kubernetes. It's useful for stateful applications, and a stateful application is one that relies on persistent data like a database. An IWS is also classed as a stateful application within Kubernetes and OpenShift. And the goal of the operator is to provide that automation point for a stateful application like IWS. And that's exactly what's been provided. So the operator came in 4.1, and operators typically are provided through Operator Hub. So operatorhub.io is where a lot of them are defined, and you can test your operator out within it while developing. And then there's the Red Hat Marketplace as well. So that's the IWS agent, IWS operator is now available through Red Hat Marketplace. If you want to know more about operators, the link at the bottom is the O'Reilly guide for it. So you can get the free ebook through Red Hat. You just have to put your details in, and they send you a link to the PDF. And that's a really useful book. So if you want to know more about operators, and if you're going to be doing IWS on OpenShift, I would thoroughly recommend that you you download that ebook, and yeah, be some bedtime reading for you. Okay. So what's actually provided? So originally, OpenShift 4 support for IWS was provided in 9.5 FixPack 2. There were two downloads that were available from IBM Fix Central, one for the agent on its own, and another one for the MDM and DWC. Both used the IWS operator. So what was provided is a set of YAML files, and the operator itself was downloaded from the Red Hat key.io repository. So that's where the registry was. But then there was a further release, which it's become known as FixPack 2.5. That was one of Franco's terms, but that's documented on the IBM Knowledge Center. And the way that one works is that it pulls it from the IBM container registry. So the IBM container library is where it's defined, and you need an IBM ID and password. And it checks it against your current entitlements to make sure that you're entitled to use IWS. And then you can get a token or a key that it generates, and then you can use that as your pull secret to actually download the operator. And we'll see that within the demo itself. So what we've done within the demo is that we've started with FixPack 2 and just the Fix Central agent as part of the demo, which is fully working. And then recently we've installed the FixPack 2.5 version, but there's a couple of problems with that. But we can see what it looks like as part of the demo. So there's effectively two versions, but Franco, if you're on the line, in FixPack 3, is that the two mechanisms still going to be available, or is it going to be consolidated under the IBM container registry?
The strategic way is to use the entitled registry, but we saw that there was some issues from some customers. It's not so usable, so it's hard to use. So when you said about in OpenShift, it's easy to connect the entitled registry and get the content from there. From other environments, some customers problem. So I think that at least for a while we'll continue to publish both on Fix Central and the entitled registry. But long term, the idea is to have only the entitled registry.
Is that because some customers are air gapped, so can't actually go out to an external repository?
No, just for example, it's hard to list the containers available on the entitled registry. That's something that it's very hard to do. So also in that case can be a problem. Maybe also how IBM is setting passport advantage and entitlements can cause issues. So try the entitled registry first. If you're not able to work with that, use Fix Central as workaround.
Right. So for FixPack 3, both will still be available.
Yeah. Anyway, you can even open a case so we can better understand why it's not easy to use the entitled registry, because the goal is to use that one. That should be much easier for upgrades, installations, and new deployments.
Yes. Okay. And then in terms of the installation process for FixPack 2.5, these are the steps that are documented in terms of how to create the new operator, the IWS operator within the operator hub within OpenShift. So what you can see in the screen on the left-hand side is what we'll be demonstrating and actually going through that. But the steps are to create a new project, apply any security restrictions that aren't already in place, and that's typically something that your OpenShift administrators will do. You create the pull secret for the IBM container library. So once you've got your API key, to put that in as a secret and point it towards the IBM container repository.io service, and then you deploy the operator itself using something called a catalog source, which is the definition within Red Hat Marketplace and the operator hub, to actually pull that information from the IBM registry using the secret that you created. And then you check to make sure that the operator pod is running, and then you can start deploying the IWS resources. And those resources are the agent, manager, and DWC. Typically, most organizations will start with just the agent side of things. You'll want to deploy or give access to your developers the ability to deploy agents within OpenShift, but maybe keep the management side of things for IWS administrators, or even keep the management side of things outside of OpenShift. Okay, so let's move across to OpenShift itself and actually show you what's been put in place. So the demonstration itself was originally created to show how IWS can integrate with OpenShift for Red Hat partners. So we actually presented this as part of a roadshow to Red Hat partners, and typically those organizations are development agencies. So they're out creating applications on behalf of their customers and recommending applications to their customers that they then use within OpenShift. And we did it as Elyzium's managed service for IWS, which is called Job Executor. So we'll see how that's done. But what we can see here is, firstly, we've got the administrative view. Can everyone still see the screen? Firstly, I don't want to be talking to
yeah, fine for me.
A group that can't actually see the screen. Okay, great. Thanks for that. So this is the OpenShift platform itself, and the first thing is that we're looking at it from an administrator's point of view. So these are all the things that an administrator can do. Everything from user management through to looking at the workloads themselves. So pods, deployments, all those things that we spoke about earlier. These are all Kubernetes services, but all brought together in a single graphical user interface under OpenShift. And that's one of the key values that OpenShift provides. Kubernetes has its own dashboard, but it's pretty limited. And the external integrations with other applications are not there either. So having it all under the OpenShift umbrella is really easy from an administration point of view. But the piece that we'll be looking at, and we can see that the version of OpenShift that we're using here is 4.5 revision 15. When we started on this, which was back in October, it was running at 4.3. So it's been upgraded by the administrators of this environment within that time, and it's now at 4.5.15. And it's actually, the OpenShift cluster itself is running within IBM Cloud. And what we can see in terms of what's available, it's a fairly small infrastructure, so it's only three nodes, 3K workers, but we have 190 pods that are running on it. And there's quite a lot of applications that have been installed. And one of the things that I wanted to say to Franco is that one of the applications that's been loaded on here is Multi-Cloud Manager. So when we get to Fixpax 3 and the integration that's going to be available with MCM, we'll be able to test it out within this environment. Okay, so we can see, oh, what's it doing? I seem to have zoomed in. There we go. We can see from the operators side of things within the administrators console that we've installed 2 operators. That's the one that we set up for the demonstration, and we rebranded it as Job Executor. And then this is the 2.5 Fixpack. And this is what it looks like out of the box. So we can create a workload automation operator within a project. If we take this off, we can see that in terms of the catalog, there's 170 different items that are in here. These are all the applications that are available that have been loaded within this OpenShift infrastructure. So if we look at the agent side of things, we've seen that we created this at the beginning of October and modified it so that it looked like the service that we provide. This connects to our master and backup master within IBM Cloud, and is available to OpenShift customers. Okay. The other things that I was going to show you. So if we look at the operator itself, we can see what can actually be deployed is the agent side of things. And we'll see that there's an agent that's already been deployed. It's running and connected to the master domain manager within Job Executor. You can see that it's installed successfully and jobs can run against it. So from the operator itself, we can see how it's been set up, and that's that single service control for all the agents that are running within this OpenShift infrastructure. And this is from an administrator's point of view, but it's typically not the administrator that actually sets up the agents, it's the developers that will go ahead and do this. So if we switch over, we've got a developer view against this particular project. And what we can see is that what's been set up is a Node.js instance, which runs an application that sits on top of a MongoDB, and it connects to the agent that we saw running, the operators there as well. But this is the agent that's running. And what happens is that this Node.js application sends REST API calls to the master domain manager, runs jobs and job streams, just like any other environment, and then anything that needs to run within the project itself, like delivering data back to the application, is run through the agent that runs within this project. So all of the different components that are available within your on-premise infrastructure is available within OpenShift, and it's the developer that actually deploys the agent. You give them access to it within OpenShift, but the way they do it is by adding from a catalog the actual agent itself. So they can go ahead and create the agents, and then the way the agents themselves are configured is through the YAML file. So this is the one that's running, and we can see which services it's using and the details associated with it. But the central configuration determines which master it connects to, how much resource that it uses. That's all determined by the operator, the IWS operator. So when it spawns the agent, you can control all of that information centrally. So the administrators look after the operator, the IWS operator, and then developers have access to be able to deploy agents within the projects that they're running as part of a platform as a service. Okay, does anyone have any questions? Is anyone still there?
Hey, Probal. So earlier on slide 15, you had a reference to 3 layers of applications. So part of it was the OpenShift admin piece. There's the applications that are developed by users, and then there was that mid layer. I just wonder if you had, how you see the masters sitting in that equation. Do you put them in the mid layer, or would you expect them to be in the development line?
They're in the mid layer. They're an application service. The developers then use the application service as part of their development build. But yes,
and how
IWS, in my opinion, sits within the application services, unless Franco disagrees.
No, I agree.
Good. I got something right then.
Yeah, okay.
While the agent should be on the developer side.
I mean, is that a typical question? Who manages that application services layer? Would that be the OpenShift administration team?
It can be, or they can delegate it to yourselves as the scheduling team.
Okay, something to run by our OpenShift teams for sure. Thank you.
I would imagine that they would want you to do it because you're the application owners. They're the provider, the platform provider for that application.
Yeah, no, it makes sense to me, certainly. And then from an agent's perspective, does that sit under developer services because it's deployment by a developer upon need?
Yes.
Yeah, that's my vision. That's my vision as well.
Yeah.
So basically, also from a project or namespace on Kubernetes, they're the same concept, just different words. So the idea is that you will have your own namespace project to run the servers, the server side on AWS. That will be part of the service that you're offering to developers. And then each development team will have their own projects, and they will deploy an agent in each deployment. Also to segregate and manage the permission that that agent has in terms of connections to call the different services, in terms of permissions to run Kubernetes jobs, this kind of stuff. So the agent as part of the developer service, they will have its own service account, and they can manage the security directly there.
Cool. Thanks, Franco.
I have a question.
Okay. Does anyone go ahead?
So just quickly, what are the pros and cons of having the master domain manager on premise outside of OpenShift versus deployed on OpenShift? Is it 6 of one, half dozen of the other, or is there a preferred, simpler to configure initially option there?
For you or for me, Probal?
You go ahead, Franco. You're the expert.
Okay. From functional perspective, the only difference is that the master on Kubernetes only supports dynamic agents, does not support FTAs. So that can be one reason. From an agent perspective, so from the developers that need to deploy the agents, that will be completely transparent. So they don't see any different. The master can be in the same cluster, different cluster on premise. That's completely, absolutely the same. So I think the choice here at the end is up to you, how you want to manage, how do you want to leverage the Kubernetes in order to improve availability, simplify the upgrades deployment, or if you prefer to have virtual machines and support for FTAs, for example.
Okay, that makes sense. Thank you.
Yes, I'd agree with that. And I think it is also to do with control as well. depending on how much control you have within OpenShift for the IWS application. If there's things that you can't do and you have to go back to the OpenShift administrators, that can become frustrating. Okay, does anyone else have any questions? Okay, I'll take that as that you don't. The last thing I'd like to say about this is the environment itself. We've got full admin rights to it and full access to it. If there's anyone that wants to test anything out or learn how to do things, kind of shake it and break it type of approach, then please let me know and we'll see what we can do. I'm sure at some point they'll take the environment away from me, but until they do, we're going to continue using it. And as I was saying, that the next thing is when Fixpack 3 comes out in December, we'll be loading it within the environment because multi-cloud manager's in there as well. And I want to see how IWS looks within MCM. And I take it that's still within the Fixpack 3 roadmap, Franco.
I'm sorry, Probal, say again?
So Fixpack 3 was supposed to have integration with MCM. Is that still the case?
No, we discussed that, but at the end we have not found the specific integration points with what is inside MCM. So it's available as on OpenShift, but there is no specific integration with MCM. So specifically with Fixpack 3, the main announcement will be to the possibility to migrate to OpenShift Kubernetes from on-premise, just adding initially the Kubernetes deployment as a backup master. So that you can perform a parallel upgrade if you want to move from on-premise to Kubernetes.
Right. Okay. And do we have a date for Fixpack 3?
Currently, it's estimated by the end of the year.
Okay. So the end of December.
Yeah.